Hello class, today we're going to be learning lesson 5-1 in our textbook. This is about learning how to describe angle pair relationships. So we know in the past couple days we've been learning about lines, line segments, rays, and we can see that when they intersect, they're going to meet and form an angle. And so today we're going to be talking about different scenarios where the angle pairs that you see of two angles have different relationships. And the first one is called complementary angles. And this is a term that we're going to call any angles when they add up to 90 degrees. So this is two angles that add up to 90 degrees. You may have learned this before, okay? So let me just draw a couple angles. And these are not fully accurate. So I have one angle right here. We're going to say that this is 30 degrees. And another angle. Let's see how I want to draw this one. That looks pretty good. I'll say that this second angle is 60 degrees. If I see that 30 plus 60 equals 90, then these two angles are called complementary angles. Okay? Another way that you might see these angles and their relationship is adjacent angles. And that just means that they are side by side. So for instance, I can have two angles that are right next to each other, like so. And because they both share this common ray right here in the middle, they're called adjacent angles. And if one of these is 70 degrees and the other is 20 degrees, and I see that when I add them together, they add up to 90 degrees, then they are also complementary angles. So this is really important to know for different scenarios. And here's one. In this example, we can see that angle 1 is a complement of angle 2. So already we're told in the beginning that both of these angles, angle 1 and angle 2, add up to 90 degrees. And if we know one of those angles, if the measure of angle 1 is 68 degrees, we can easily find the measure of angle 2. I don't even need to draw a picture of this. I know that angle 1 and angle 2 must add up to 90 degrees. So if angle 1 is 68 degrees, I can easily find the second angle by simply subtracting 68 degrees from the 90. And I'll see that the measure of angle 2 is in fact 22 degrees. Real easy. Now another term that you're going to notice that I have up here is called supplementary angles. And supplementary angles are a little similar. It is again just two angles, but this time it's two angles that add up to 180 degrees. So again, I can have two angles that are not touching. So let me draw a couple right here. We'll say that this first angle is maybe 20 degrees. And then I can have another angle that's going to be spread open pretty wide. Let's see, maybe something like that. And this one might be 160 degrees. And I can see that if I add 20 plus 160, that's going to add up to 180 degrees. Similar to when I was working with these complementary angles, I can also see them in some scenarios where they're side by side. And that means that they are adjacent angles. And you'll see that instead of them forming a 90 degree, they're going to lie what looks like on a straight line. So this might be 110 degrees, and this one might be 70 degrees. And I can see that when we add them together, they're going to add up to 180 degrees. These are called supplementary angles. And in the same way, I can have a scenario where I'm given one of the angles, but not the other. But if I'm told, like in this example, that angle 1 is a supplement of angle 2, and I know the measure of angle 1 is 56 degrees, I can easily find the measure of angle 2. By adding them together, they should equal 180, so the measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees. So angle 1, we're told, is 56 degrees. I don't know the measure of angle 2 yet, but all that I have to do is subtract 56 degrees from both sides. And then the measure of angle 2 is going to equal 124 degrees. This is easy stuff that you've probably learned before. A couple other terms, because that's mainly what we're dealing with in this section, is the term linear pair and also the term vertical angles. So let's go over what a linear pair is. And it's actually related to what we just talked about with supplementary angles. A linear pair is two adjacent, so that means next to, adjacent angles that are supplementary angles. Okay, so this is pretty self-explanatory. It just means that there are two angles that are next to each other and they add up to 180 degrees. So I can have angle 1 and angle 2 and say that both angle 1 and angle 2 form a linear pair because they are adjacent angles and they're supplementary. They add up to 180. So in this example, it says that two angles form a linear pair. So right off the bat, when I see this term linear pair, I know that they add up to 180 degrees. It says 1 is 5 times the measure of the other. So find the measure of each angle. So I don't know, it kind of helps me sometimes to draw a picture. It might help you as well. So I'm just going to sketch a picture. I don't know the measure of these angles yet, but I know that they are a linear pair. They're lined up on a line. And one of them is 5 times the measure of the other. So the bigger one is going to be 5 times the measure of the other angle. So if I don't know either one, I'm going to label one as x and the other is 5 times that. So I know that 5x plus x, when I add them together, they should equal 180 degrees. This combined is 6x. And simply if I divide both sides by 6, I'm going to find that that x is actually 30 degrees. So the smaller angle is 30 degrees. And if I plug the x in here for 30, 5 times 30 is 150 for the other angle. So I found both of my angles. Problem solved. The very last term that we're going to go over is vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. We're going to learn a lot more about vertical angles later, but let me just show you a picture of what I mean. Let's say I have this line, okay, and maybe I have some points on this line, and I'm going to label them A, B, and C. Well, we learned already that from the ray BA and the ray BC that those are opposite rays. They form a straight, complete line, but they're going in opposite directions. Well, if I have another set of opposite rays that are going to go through this middle point, let's label this maybe D and E, the angle that is formed by the sides of two opposite rays, these are actually vertical angles. So let me get another color just to show you. This angle right here, angle 1 and angle 3, are a set of vertical angles. They actually form a V, if you can see that, so that might help you remember. But angle 1 and angle 3 are vertical angles. We can see that their sides are formed by opposite rays. Also, this one up here, if I label that angle 2 and this one down here angle 4, those are also vertical angles when I compare them to each other. So they're always right across from one another. And this is all that I want you to know about vertical angles at this time. We're going to learn a lot more later on. So I'm going to leave you with one practice problem based on all of this knowledge and all of these terms. On your own, we're told that angle X, Y, W, and also angle W, Y, Z form supplementary angles. So look back, what does supplementary angles mean? That they add up to how many degrees? So based on that knowledge, if I know that X, Y, W is 2x plus 14, and if I know that W, Y, Z is 4x minus 20, I want to find out what X is, plug it back into both of them to find their true angles. So go ahead and try that on your own. Come back with any questions that you have at class, for class, and I will see you later.